Welcome back to the channel. This video is on atmospheric science and meteorology. We're looking at cloud types, the 10 main or principal cloud types, their levels, and their brief descriptions and characteristics. This is the Earth Science Classroom. There are 10 main types of clouds, and of these 10, they are split or divided into different categories based on where they form and where they exist in the atmosphere at different altitudes. And this comes down to low-level clouds, medium-level clouds, and high-level clouds. Now, low-level is between the surface and around 6,500 feet. Mid-level clouds, or alto, is between 6,500 feet to around 23,000 feet. And then the high clouds can range anything from 16,000 all the way up to 45,000 feet up in the upper troposphere towards the tropopause. So the main types, we'll start with the low-level clouds. And there are three main types of low-level clouds. There are cumulus clouds, stratus clouds, and stratocumulus. Now you can include cumulonimbus clouds or thunderstorm clouds in this category, but we'll say that till last because that's a special kind of cloud. So cumulus cloud, or CU, they exist around 2,000 to 3,000 feet in the air, and they produce some precipits and showers, and they form mostly from convective uplifting of the air, contain generally lots of water vapor and lots of moisture, but they do also indicate nice weather with stable atmospheres. So that means that the atmosphere is somewhat stable, and the cumulus clouds are built, but they stay at a certain altitude and not going to continue to rise with any kind of vertical development. Cumulus is wider than it is tall. Meteorolus is the same width as the clouds are tall, and then congestus means that they're narrower than they are tall. Then we've got stratus, which means layered. It is advective or movement across the Earth's surface, the atmosphere, collecting more and more clouds and becoming more combined as a single cloud mass that is in stable conditions, wide and not very tall. This is ST, the abbreviation, and this is where you have a large area of moisture and big temp difference, and you get these large, wide, flat clouds forming the atmosphere between the surface and 6,500 feet. So they happen at the surface, or around the surface. We call it fog. And this is the lowest cloud type you get. This also happens around mountains and coasts and valleys, and also around temperature inversions. This produces light drizzle and some showers, and generally very cloudy skies. Then we got stratocumulus, which is SC. This is a combination of both strato, which is layered, and the cumulus, which is the heap of cloud. Now this is generally low and fluffy and larger than cumulus. They're connected, and they form between 2,000 to 6,500 feet in elevation, and they can produce light rain, and they become more continuous clouds in the sky, so a lot more overcast than cumulus. Cumulus is that partly sunny, and the wind and the air pressure and the unstable conditions can create these clouds to join together and form stratocumulus than just stratus or cumulus by themselves. So these next cloud types are all to do with mid-level clouds, or the word for mid would be alto, these alto clouds. So you have altocumulus, altostratus, nimbostratus, and these all reside or form between 6,500 feet up to around 23,000 feet. Now the altocumulus, they form between 6,500 feet to 18,000 feet, and the abbreviation is AC, and they form through atmospheric disturbances, some ice, some water combinations, different temperature differences, and also altitude is controlled based on what you're going to have in the cloud, whether it's water, rain, or ice, based on the temperature. So this is, again, the heap of cloud, same situation as the cumulus and the low-level cloud. However, you're going to have a warmer atmosphere, so the cloud's going to form higher and reach that dew point at a higher altitude compared to the lower level altitude. Altostratus, or AS, is the same situation as the altocumulus, where you have the similar low continuous flat stratus cloud, but it's forming in the middle of the atmosphere, the troposphere, between 6,500 feet up to a max of 23,000 feet. And it's a stable atmosphere, but you have this air that's descending to keep it at certain heights and keeping it flat, but also you have that warmer lower atmosphere to bring that dew point up higher to a higher altitude. The next alto or middle cloud is nimbostratus. Now, these two levels of cloud represent one of the coolest clouds out there, which is nimbo means it's producing rain or precip, and stratus means it's a large continuous flat cloud. So the two together creates this very unique cloud. And it does go down to about 2,000 feet, but up to a maximum of 18,000 feet. So it does go between those two levels, the low level and mid level. However, the accumulation of the altostratus and the more of the clouds joined together in a stable atmosphere can create this nimbostratus, where you're just overloading the water vapor and moisture within the cloud in the stratus to create this nimbus effect to cause precip. And again, based on temperature, atmospheric pressure, and the amount of water vapor that is condensing at the dew point and the LCL. And as rain occurs from this cloud, the actual cloud base becomes lower in the atmosphere and decreases in altitude, which is really cool. Now, the next cloud layer is the high cloud layer. The clouds that form in this layer are defined, again, by temperature. It's so cold up in these altitudes because of the lapse rate and adiabatic cooling, and you're going further away from the Earth's surface, which is the heating source, that up towards the 20, 30, 40,000 feet altitude, you're getting extremely cold temperatures of minus 20, minus 30, even as low as minus 40, minus 45 at the tropopause, where any water vapor is going to condense into ice crystals. Now, these ice crystals can form in different amounts, different shapes, different patterns based on the wind, updraft, and the availability of water vapor and what kind of turbulence is up there in the upper troposphere. The first cloud type for high is cirrus, which is CI abbreviation. It's stable conditions. Upper tropospheric winds are creating this cloud. It's ice crystals, it's streaks or curls of hair that you see really high up. It's showing limited moisture up there in the higher troposphere, and it's lifted based on the updrafts, the gentle updrafts, and the shapes and patterns can reflect these updrafts, these curls in the wind, which is represented by the shape and pattern of the cirrus clouds. Next is cirrocumulus, which again is more of a rippled accumulation of more water vapor, but still ice crystals that accumulated in larger amounts. And this is CC for abbreviation, and this is going to be an increase in moisture, increase in winds, and it looks to appear from the ground to be rippled as you look at these clouds. And it could mean unstable conditions, or it could also mean that some air is rising, some air is sinking based on temperature and pressure around that part of the atmosphere. But really cool clouds to see. The last main high cloud type is cirrostratus, which is CS abbreviation, and these again are thicker, longer streaks, longer accumulations. They occur between 20,000 to 42,000 feet, with the average around 25,000 feet, and they kind of make up this larger ice crystal accumulation with more moisture, and you have these adjoined cirrus clouds together. So you have this wind pushing these cirrus clouds together, and it can form the cirrostratus. Then finally, our 10th cloud type, which is our cumulonimbus, which is our thunderstorm cloud, which is our special cloud, because the other clouds I've mentioned, all 9 previous, are clouds that kind of develop horizontally. They develop at certain altitudes, and they kind of, besides nimbostratus, they kind of stick to their area. They stick to their formation and altitude and zone of low, medium, high, whereas cumulonimbus is a 3-level cloud which can form as low as 2,000 feet and go as high as 45,000 in some cases. Even pop over the top of tropopause and have an overshoot. Now, these clouds are both terrifyingly beautiful and can create some of the most amazing extreme weather we have on this planet, like tornadoes and lightning. And these clouds form in certain stages, and certain patterns, and they form and dissipate over time based on the atmospheric conditions, the temperature, and they require certain amounts of water vapor, certain wind, certain pressure, and certain wind shear. And if they have the right conditions, they can create these extreme weather and amazing clouds like wall clouds and funnels and tornadoes and spinning vortexes and these massive supercells which spin slowly around, and it's just an awe-inspiring cloud. You admire the beauty of this cloud. Thank you so much for watching the video. I hope you enjoyed it. If you like it, please subscribe and maybe hit the like button. If you like more on this content, please check out my channel, which has all these videos on Earth science.